Hola a todos y bienvenidos al canal. En el vídeo de hoy queremos llevar a cabo una actualización de la apasionante misión OSIRIS-REx al asteroide Bennu. Y es que se aproxima uno de los hitos más importantes de la mencionada misión. El próximo 20 de octubre la nave descenderá hasta la superficie del asteroide Bennu y por fin tomará una muestra del mismo para en un par de años traerla de vuelta de regreso a la Tierra. Nosotros hemos tomado parte activa en esta misión de una manera modesta a través de las plataformas de ciencia ciudadana, en concreto a través de universe.org, en el cual miles de voluntarios hemos realizado un mapeado exhaustivo de la superficie del asteroide con el fin de escoger el mejor lugar de aterrizaje para la misión. Al final se escogió un área que ha sido bautizada como Nightingale y de la cual tenéis detalles en este vídeo, incluso detalles en 3 dimensiones y comparaciones con objetos terrestres para que seamos conscientes de la extrema dificultad de esta misión. También encontraréis en este vídeo un sorprendente hallazgo, y es que a través del análisis detallado de la superficie de Bennu, de cada una de sus rocas, a través de métodos espectrográficos, se ha descubierto que varios grandes rocas provenientes del asteroide Vesta forman parte del asteroide Bennu. Realmente esto es un hallazgo increíble y también encontraréis detalles de él en nuestro vídeo. Además, podréis descubrir cómo la misión OSIRIS-REx ha realizado un récord, y es que ha sido la misión que más cerca ha orbitado alrededor de otro cuerpo celeste. Bueno, la verdad es que es una puesta al día de esta misión que se acerca, como decíamos antes, a su punto álgido. Espero que disfrutéis de este vídeo. Os animo a suscribiros y a darle a me gusta y a compartir nuestros vídeos. Muchas gracias. Un saludo.
Over 200 million miles away from Earth. In late 2018, as NASA's OSIRIS-REx spacecraft neared its target, Bennu, the asteroid grew in detail from a few tiny pixels to an incredibly high-resolution image. OSIRIS-REx confirmed the asteroid's basic shape, which was originally observed in 1999 by ground-based radar at Arecibo Observatory. What scientists didn't expect was just how rough and boulder-filled the asteroid would turn out to be. While it can be difficult to fully grasp Bennu's unfamiliar surface, it's helpful to understand the scale of what you're seeing here. In this image, the brightest boulder is the length of a horse, and the large boulder in this image is the width of a soccer field. Another challenge for the mission is the asteroid's small size and weak gravity. This means that OSIRIS-REx needs to fly daringly close to the surface in order to enter into orbit. With its orbital A phase, OSIRIS-REx successfully entered the closest ever orbit for a spacecraft, setting a Guinness World Record in the process. Then, 6 months later, it beat its own record during its orbital B phase and approached to within a few hundred meters of the rocky surface. Because OSIRIS-REx flew so closely over the surface during orbital B, the team was able to map the topography and shape of Bennu better than we have our own moon. In addition to mapping asteroid Bennu, OSIRIS-REx plans to collect and return a sample back to Earth. To do that, the spacecraft will carefully tag the surface of Bennu. Last December, the team officially selected sample site Nightingale as the tag location for OSIRIS-REx. Over the past year, the spacecraft has been closely imaging the site and conducting rehearsals in preparation for sample collection. What was originally envisioned as a smooth and easy touchdown on Bennu's surface has become a complex endeavor to tag a small, crowded space on the asteroid, an area no larger than a few parking spots. The OSIRIS-REx team has already pushed the boundaries of scientific exploration, going from ground-based radar images all the way to being a few hundred meters from the asteroid surface. It appears some pieces of asteroid Vesta ended up on asteroid Bennu. According to observations from NASA's OSIRIS-REx spacecraft, the new result sheds light on the intricate orbital dance of asteroids and on the violent origin of Bennu, which is a rubble pile asteroid that coalesced from the fragments of a massive collision. 6 boulders, ranging in size from 5 to 14 feet, were discovered scattered across Bennu's southern hemisphere near the equator. These boulders are much brighter than the rest of Bennu, with some appearing as much as 10 times brighter than their surroundings. The unusual boulders on Bennu first caught the team's eye in images from the OSIRIS-REx camera suite instrument. The team analyzed the boulders using an onboard spectrometer, which separates light into its component colors. Since elements and compounds have distinct signature patterns of bright and dark across a range of colors, they can be identified using a spectrometer. The signature from the boulders was characteristic of the mineral pyroxene from Vesta and the Vestoids, smaller asteroids that are fragments blasted from Vesta when it sustained significant asteroid impacts. The team tested a few different theories to determine the origin of these boulders. First, it's possible that the boulders were originally part of Bennu or its parent body. However, this is unlikely based on how pyroxene is created. This mineral typically forms when rocky material melts at high temperature. Bennu is composed of water-bearing minerals, so it wouldn't have experienced very high temperatures in its history. Next, the team considered localized heating, perhaps from an impact. The scale of an impact needed to create large pyroxene boulders is much more significant than what is expected to take place in the main asteroid belt. So the team ruled out these scenarios, and instead considered other pyroxene-rich asteroids that might have implanted this material to Bennu or its parent. This is possible because as asteroids move through the solar system, their orbits can be altered in many ways, including by the pull of gravity from planets and other objects, meteoroid impacts, and even the slight pressure from sunlight. The new result helps pin down the complex journey Bennu and other asteroids have traced through the solar system. Over 200 million miles away from Earth, NASA's OSIRIS-REx spacecraft is preparing for an ambitious sample collection attempt at asteroid Bennu. Before it makes its approach to the rocky surface, let's take a look back at some of the incredible firsts for this mission, which almost seem like something out of a Hollywood movie. This is the first asteroid sample return mission for NASA, and it could be the largest return from space since the Apollo astronauts brought moon samples back to Earth. While getting set to grab a sample, OSIRIS-REx has set not 1, but 2 Guinness World Records. Its first for the smallest ever body orbited, and its second for the closest orbit of a spacecraft. This tight orbit has brought the spacecraft so close to Bennu that OSIRIS-REx's onboard cameras and laser altimeter have been able to image and characterize the asteroid's surface and shape better than Earth, our own moon, or any other celestial body. OSIRIS-REx has imaged Bennu down to 5 cm per pixel resolution, providing us with an unprecedented view into this rocky and boulder-filled world. With 28 onboard thrusters, OSIRIS-REx is one of the most maneuverable spacecrafts. This allows it to carefully and precisely descend to a spot on Bennu that is no larger than a few parking spaces. There have certainly been some unexpected twists along the way. However, OSIRIS-REx has capitalized on these moments. Right after arriving at the asteroid, OSIRIS-REx imaged rocky ejecta that has been bursting off Bennu. This is the first time we have been able to observe the entire life cycle of a natural satellite ejecting off an object, entering into orbit, and returning back to the surface. Because of Bennu's extremely rocky surface, the team needed to adapt the spacecraft's navigation method to an optical approach known as natural feature tracking, or NFT. This is the first time this approach has been used in space, and it will allow OSIRIS-REx to steer itself down to collect a sample from Bennu.
And now, OSIRIS-REx is looking to set another first for NASA. Successfully collect a sample of an asteroid and deliver it to Earth by 2023.